All right, welcome everybody. It's the last session. Good job, gold stars for all of you for sticking around. In case I forget at the end, please, if you can remember, do the reviews or the session feedback. It's really helpful. Okay, so this is Cloudy with a 100% chance of data. For those of you that don't understand the title, it's a reference to a children's book and some movies about an inventor. His name's Flint Lockwood. And he creates this machine, goes up in the clouds, and it creates food. And the food just like kind of rains down on his town, and the food mutates and gets larger, and then starts attacking people, stuff like that. But those of us at conference, we know what the movie's really about. It's about the benefits and challenges of self-service analytics. I'm sure that's what you thought about the whole time that you're watching this movie. It's like, oh yeah, this totally makes sense. It's about data. My name is Philip Chung. I'm the product owner for our data platform team at Tableau. This is the second time I've done this talk at conference. So this officially marks the end of my extrovertedness for the year. And yeah.
So I'm Kevin Bosky. Like Philip said, this is our second talk this year. I'm doing this talk because of my sins of my former past, because I used to test and work on SQL Server. In fact, I used to test SQL Server replication, which will become apparent as to one of the decisions we're making to go to Snowflake as Philip talks.
So Kevin and I are both part of our enterprise analytics department. And our mission is to drive self-service analytics across the enterprise at Tableau. Our team supports both the underlying database platforms, so all of the data infrastructure, as well as how we use and deploy desktop, prep, server, and online. We're going to tell the story today about why we're moving our infrastructure into the cloud and a little bit about how we're doing it. But first, before we get into that, we'll go back in time a little bit. Tableau, like many companies, grew as a startup with a single but pretty audacious goal to help users see and understand their data. Desktop was our first product that we released. And early on in Tableau's company growth, we started connecting desktop to databases because we wanted to see hey, let's get real-time access to the data. Let's have some centralization around that we're all accessing the common set of data. And if you search on our website, you can find some blog posts from long ago from one of our founders about how we analyzed our CRM data and our defects data to help improve how we operate Tableau and how we build the product. So in the early days of Tableau, it was figuratively raining data. We had more than enough to explore and discover new insights. And basically, all was good in the world and everything was awesome.
Well, at least that's the story we were told. When Philip and I joined 6 years ago, we had a SQL server and a Tableau server that were running all of our analytics business internally. We were pulling all of our data in. We were publishing that data out as vizzes. Things started to grow. Tableau started to grow. We started to put up sales offices all over the world. The employee numbers grew. At some point, we got to this point. We're scaling at 3,300 employees. We have 196 server cores. I have 2 admins on my team managing that. We upgrade often. Internally, we do what we call dog fooding our product. If you're not familiar with the dog fooding term, it's a term for eating your own dog food, using your own product, testing it out before it goes to your customers. As I said, we have 2 admins that manage all of this today. We've got 7 developers who build the ETLs that bring the data into our warehouse. We have a couple of DBAs that do that. That doesn't include all of the IT support, those people who are running the networking, running the hardware. All of this is going on.
So on top of just the growth of Tableau as a company, as we're growing, we also were starting to hit technical limitations on what we could do and how we could provide the data to our users. SAN storage is expensive, and we just never seem to have enough of it. There was a lot of infrastructure that we were managing all the time, and it was hard to kind of stay up to date with all the stuff that's happening with just making sure that the machines are running fine. We'd have to go and talk to our users a lot and say, hey, analysts, what tables and fields do you need? Do you really need that? Because that means we can't have this or that, and it'd be these tough conversations that we'd have to have. And at Tableau, that doesn't go over well because our stock ticker is data. So there's an expectation that we should be able to have data. So for us, how it felt for Kevin and I is that there was always this oncoming data storm with every new project or every new initiative, and we were always like trying to kind of keep up with and just barely keeping up with just the massive growth of how Tableau was growing as a company. So we were spending most of our days trying to keep up with requests from yesterday or last week and last month. And instead, and we weren't able to really do the planning that we need to do to be where we were going to be tomorrow or the needs that we would have next month or next year. So that kind of sets up our thinking. We're like, okay, we have some of these technical limitations. We're having a lot of growth. It's hard to predict all of these things. It sounds like the cloud is suited for that. So a couple of years, actually about a year ago, we took a step back and our teams talked about where do we need to be, what do we need to do, how are we going to get ahead of all these data storms. One of the first things that we were interested in is we wanted the flexibility to be able to adjust to changes in data demand. The concept of scaling up and down quickly is just not something you can do with an on-premise system. But that's what the cloud is pretty much designed to do. So that's a core trait of the cloud. A quick story about this one. We had a pretty maybe normal request a couple weeks ago where we wanted to do a one-time load of about 1 terabyte of data. So we wanted to load this into our database. And if we were on an on-premise system, how we would have approached this first would be, well, let's do that on a weekend or maybe at night because we're going to be stressing the system. We don't want to affect service. We probably split that terabyte load into lots of little mini batches and make sure each one kind of goes through and just kind of process them one at a time. It'd take a lot of coordination. It'd take a lot of planning. It would take maybe some communication with our end users to say hey, the system might be affected at this time. But with Snowflake, our cloud data warehouse, for this request, we had a single team member who just, as a request came in, said, okay, I'm going to scale up the infrastructure, and I'm going to do the load. It took about 5 minutes, and then we scaled it back down. Total cost for us to do that one task was less than $50. And you didn't have to plan anything, didn't have to notify anybody. It totally happened transparent. So, that's just one example of a different way of operating and a different way that we can handle these day-to-day requests. Another trait that we were looking for is we really didn't want to think about the size of our data or how much data we needed. We didn't want to have those, didn't want to be limited by storage or compute processing. So that example I gave where we have to talk to users and say, oh, can you tell us why you need this data? What are you going to do with this? At Tableau, we've tried that. We've tried asking those questions. The response is usually, I don't know. I have to explore it. I need to see what's going on, and I don't know exactly what we're going to do this, but I think that I need these fields. And so those conversations were really difficult for us to have because we understand the request, but we just weren't able to fulfill it well. But in the cloud, we're not limited by storage and compute. The storage is really affordable. It's not something that really becomes a factor. We had to go through a couple of exercises with the team to actually get our heads into that space where we're saying, well, actually, we just spent 15 minutes talking about this, but if we do the math, it's 75 cents? Is this really worth even talking about? Another one of our goals, and this one is less technical, but we wanted to change the conversations that we have with different teams in Tableau about what is your data request. How many have ever had the conversation where you had to explain why a query was slow or why it was complicated or why? Yeah, it's challenging. It's well, because look at this thing, right? Like we're scrolling through your SQL, right? So it's a hard conversation to have. And what this one is really saying, or this objective is, we just wanted to have some more language around complexity. And by moving to a cloud system, we're now actually able to quantify performance in a dollar amount. So it's still complicated. We can still fix it. We can still model it. It takes a lot of effort. But it would also cost this much if we wanted us to just scale it up. And just having that extra figure in a dollar value just really helps with the conversations that we have with our users. So they can say, oh, yeah, over a year, that is pretty expensive. Maybe we really should prioritize looking at the data model or how we're doing things in the data infrastructure. So the cloud helps us just with those conversations. And then at Tableau, we operate as a cloud-first company. So the majority of our operational systems are SaaS products. And we want to experience that way of life for SaaS analytics as well. So for our team to be ready for today's demands, as well as the data demands for the future, the cloud is really a good fit for us. So we'll dive a little bit into now a little bit about how we're doing that transformation. Okay, how many of you are familiar with this term, ETL? Yeah, all right. For some of you, maybe who didn't raise your hand, it stands for extract, transform, and load. And it basically describes the 3 stages for data teams and what we do. Like how do we get the data and how do we fix it up and how do we load it in the systems or into the database. It's been a staple of data engineering for about last 30 years. And the whole concept of ETL is it's based on the premise that more data exists than you have technical capacity to process and store. That's why transform is in the middle. So transform is the step where you are shrinking the data down or you're trying to turn it into something a little more usable. You'll do aggregations or you'll do summarizations. Maybe you'll join things together. So you're trying to take all of this data that exists out there, get it into a smaller usable state, maybe a dimensional model if you're really ambitious, and then load it into the database because that's how you can actually provide your service. You have to kind of like tame this data before you bring it into your systems. So what does an ETL-based architecture look like at Tableau? So here on the left are some of our source systems. These are kind of generic. We have CRM, ERP, an HR system, project management, and finance. And here is our ETL process of how we're doing this with an on-premise system. So we're doing ETL, we're getting the data out. We're doing some business rules, we're joining things together, and then we're loading it into our data warehouse. So after we've done that, we then take a copy of that data, the same one we just got, and then we replicate it out into various other SQL servers. For us, it's SQL Server for this on-premise system. And this is the layer that actually users will connect to when they're trying to issue queries or use our Tableau products, which is on the far right, our service layer. So each one of these arrows here has some challenges that we've been struggling with. Specifically on the ETL side, as Tableau has kind of grown, this is not so much technical, but I think it applies to many of your teams maybe as well. We've inherited some processes that somebody else wrote and have tried to scale. And so not all of these things are the same way, same programming language, same process. Sometimes we're using middleware to be that connector to the different source systems. So our ETL process right now is hard to manage and hard to maintain. We're often in the situations like, oh, we have a question about our HRIS system. Anton's on vacation. Can we wait until he gets back so that we can answer this? That's not a great place to be, but it is where we are because we've just kind of mashed things together. We also have challenges on our replication side. Replication is a common technology that database systems have where you're copying data and you're keeping them in sync. So as new things kind of come in or as updates come in, they get replicated out to the various data marts. On our finance team, they run a business process where once a month they create all of the revenue entries for the previous month. I imagine they're clicking some buttons and all of a sudden 10 million records appear in the system. And so we have a large wave of data that's coming through our ETL, and it's struggling to make it through our replication process into our various data marts. And then on the query side, why is my dashboard so slow? Why is my query so slow? Why did you kill my query? We do that too sometimes because we have to preserve our system, so we'll actually go and kill a query. It sounds very brutal, and it often is. But that's the constant challenge of trying to support Tableau as a self-service BI tool. Can we serve the data to these analysts and what they need fast enough? So that's our traditional ETL system, and that kind of summarizes a lot of the challenges that we have maintaining this. There's one thing that's not on this diagram here. It's kind of the hidden cost of infrastructure. So behind the scenes, we are managing servers. We are doing patches. We're doing updates. We're buying new hardware, and we're deploying, and we're moving data centers around. So we have to do all of these things, which really has nothing to do with what we're trying to accomplish. From the service layer of being able to support analytics at Tableau. So with all of these challenges, and we know that we want to be in the cloud, we did a lot of research. We did a lot of design, and we came up with a great solution. It looks a little bit like this. So we went from ETL to ELT. All we did is switch the little letters around. And yeah, that's it. No, just kidding. Yeah, it's just switching two letters around, but it really did fundamentally change the way that we think about our data pipelines and our data infrastructure service. So let me talk about that a bit. So here's that same diagram, but now from a lens of an ELT approach, and I'll explain what I mean by that. So we want to focus just on the extract and the load. So we have moved the transformation. What I mean by focusing on extract and load is that we want to take the data as the application presents it, just the way that it presents it to us. We want to take that data and load it immediately into the data warehouse. We don't want to do any transformations. We don't want to change anything. We don't want to try and insert ourselves into the business process when actually with the desktop and prep, your analysts can do quite a lot with just the raw data. And if you can deliver it to them, you can say, okay, you have Tableau, use it, here's the data, and start doing your analysis. So what happens to the transformation? It's still there if we need it, but it's an optional step. So we focus on extract and load, and then if needed, we can do a transformation after we've done that load into the system. And so we have a different section of our data warehouse. We call it our curated layer, and this is where we'll have views or database views if you need it. Ultimately, what we're hoping for, or what we're planning for, is that transformation is going to move out into our product suite. So as you heard from conference today, we have new things that are coming out, like Conductor, Prep Conductor, and the data model that is going to be enabling self-service transformations. Your analysts can actually start doing these transforms themselves. And we have existing products like published data sources or data server, where you can take all of the value or all of the things that you're doing in a database view, and you can put that in Tableau server. And you can publish that data model with a rich semantic layer and do that inside of the Tableau product suite. And you can give that responsibility out to the analysts who really do understand the data and understand what all of these relationships means and the business definitions. That is something that my team has struggled to keep up. As Kevin mentioned, we have a fairly small team, and it's really too much for us to be able to know what every single field in our CRM or in our ERP is. It's the people that are working with the data should have the ability to interpret and make these data models and do their analysis. So a cloud data warehouse really allows us to store this granular raw data. So by not having these storage and compute limitations. So at Tableau, we partner with lots of different database vendors. We use a lot of them operationally as well. And Snowflake is one of the cloud data warehouses that we feel like fits very well with this approach that we're thinking about with an ELT approach. Their ease of use and their cost structure and the ability to separate storage from compute have been some of the things that have made it so that it fits well with what we're designing. So there's one other way that we're able to support self-service analytics, and that's by providing capacity to teams to load their own data into the warehouse. So what we'll do is we'll provision sandboxes. And the reason that we do sandboxes is because oftentimes we'll get requests for like, hey, I have a project or I want to do an experiment. I don't really know the long-term viability of this. We want to enable those activities, but we don't want them to wait in our backlog for us to do the EL process, especially if it's for short term. So we'll provision a sandbox, which is basically just another schema or another database on the cloud warehouse where they can go and we give them rights and they can self-service and load the data in themselves. The sandboxes have actually been one of the most popular services that we've provided at Tableau. Can we do questions? Yeah, can we do questions at the end? Okay, thanks. Okay, yeah. So for the sandboxes, yeah, what was I going to say about the sandboxes? They're really popular. Yeah, it is one of the services that's been most popular for us. Teams have been able to load things up. And the reason that we want to provision the sandbox is because if we don't, then we don't know what they're doing. They're going and provisioning their own infrastructure or setting something up. I got a machine under my desk. At least by giving them a sandbox, we have visibility into what's going on, and we can actually say, oh, it looks like you have a lot of activity going off of these tables that are in your sandbox. Is this something that has now moved past that project phase and we now need to prioritize coming through our own EL process? So our team is building an internal service at Tableau, and we call it Metaphor. What Metaphor does is it controls that extract, load, and transform process. Metaphor is a metadata-driven ELT framework for loading any kind of data into our warehouse. So it's a little hard to demo Metaphor or our process here because there's no UI, but I'll show you some of the data that we get out of Metaphor and how we use it, so you can kind of get a sense for that. All right, so this is a modified dashboard. I blew it up so it fits better on the screen. It looks a little weird, but it looks better for presentation. This is a workbook that we use to analyze the history of our ELT process. So we have filters here for the different applications so that you can pick which source application you're looking for. So this is over at the left-hand side of that diagram. And then you can look at, here we're looking at our project management system, and you'll see that we have two schedules here that are doing our extract and load process. And here you'll see the tables that we have and what type of refresh it is. On the x-axis, we have time. So this is about a week of data from mid-October. And each mark here, or each line on this dashboard, is one instance of doing that extract and load process. If I hover over here, it'll break out a little bit more detail here. So when we extract, it actually goes through 4 steps, basically. And I'll highlight them here. So the first thing we do, this one's pretty simple. We do the extract. So we go to our project management system, and we say, hey, what's the new data in the last time since we ran our extract process? Here, we brought about 3,000 records in, and it took about 13 seconds. And then in our load stage, we break it out into 3 sub-steps. The first step we do is after we've done the extract, we stage that data, or sorry, stage is probably not the right term. We put that data in a file in Amazon S3. So S3 is our import location. And then we load that data into our staging table in Snowflake. And then we go from that staging table and we merge that data into the live table so that we're able to get new data that's come in as well as updates to existing rows. And so every time we do an extract and load process, it goes through these 4 basic steps. The width of the bar kind of indicates how long it took. Here's an example of a different table that comes from our project management system. Here we're loading about 425,000 records. This one took about an hour and 15 minutes, and you'll see the majority of that time is spent on the extract. So this is us getting a large amount of data from our source system. And then we still go through the same processes to get it to S3, put it into our stage table, and merge it in. But this allows us to kind of monitor and see how our metaphor process is working. I'll highlight just a couple other things in this dashboards. Table 15, the row here, this is a story of how we got a request from the business that says, hey, there's a new table and we want it. We set it up and it started extracting here. The first one failed, but after that, it's been pretty steady. And then here in this gap on late October 19th, you'll see that this indicates that there was a time when we were not doing our extract and load process. So this was an issue that took our service down and we had to restore it. I believe this was something with one of our middle services that we're using for orchestration and scheduling. So we had to restart that. So this is just, a quick example that shows the output of how we're doing our extract and load process. Okay. So by deferring the transformation step, we're really able to focus our processes on just extracting and loading. The cloud gives us the ability to get more data than we had previously been able to process or store. And so we're able to really scale to the amount of data that exists in those source systems. We do that by focusing on the raw data. So we're not trying to do anything fancy. We're not trying to insert our team as a bottleneck for potential requests or potential changes. So we're just saying like, hey, this is how the data is. We're putting it in the system. We're not converting any timestamps. We're not changing ones and zeros to trues and false. Tableau can do that much faster than we can. And we're not doing a lot of those things because we can leverage the power in our Tableau suite. By doing this, analysts can get access to the data faster. They're not waiting for us to do a lot of business process. We're saying, here it is, here's access to the data warehouse, and go analyze. And with the self-service sandboxes, it's a really good fit for these short-term projects and experiments, and we have visibility into them. So if ELT and the cloud allows us to store more granular data, how do we also ensure that our processes scales? Because we're handling more things now. We do that by changing our development to be configuration-based rather than code-based. So instead of specific code, so instead of one of our data engineers writing code to go to our CRM and download the account table, our engineers instead are writing code that looks, or generic code, that looks at configuration, and whatever that configuration tells them, it goes and gets. So the code just happens to go to our CRM and download the account table because that's the configuration we fed it. What that means is we don't have to deploy new code, we don't have to check anything in if a user requests a new table or a new field. Really, we're just modifying configuration and that code just kind of stays the same. So this has been a way that we've been able to improve, or a way that we've changed our development practices to scale to more options as well. So let me show you a little bit about what that looks like. So here is a specific example from Salesforce. So when I say CRM, we use Salesforce. This is an API that Salesforce provides us that allows us to see the metadata around the objects that are in Salesforce. So here we're looking at the account object, and we're able to get the length, the name, the type, the default value of all of the fields in the account table. And we can use the same API to go look at all the other objects, lead, contact, opportunity item, and we can get that key information so we know what data exists out in these applications. We are able to do this with many of our other applications that we use because they provide these APIs to let us interrogate the metadata. So this, by going out and getting this metadata, it allows us to change the conversation from, oh, we just got a request to get a new field. I know nothing about that. I don't know how long it'll take. Let me go do some research and I'll get back to you. And we're always kind of like reacting to these requests. So instead of that, we can go out to our analysts across the company and say, hey, here's all the data that we have access to. What are you interested in? And they can pick and choose. And they can say, oh, yeah, I want this field. I want this field. And after they've done that, we already have all of the information we need. We already have all of the configuration we need to feed into our extract and load process. So let me show you a little bit about what that looks like as well. Slideshow. So we built a service, we call it Schema Crawler. So Schema Crawler is actually what calls those APIs and it goes out and gets all that information. We store it in a database, and this is a dashboard that we use to show all the analysts across the company as well. It's like, here's what we have access to. So this dashboard is looking at our project management application. It's looking at table 15. And here it tells you whether or not this field is enabled in our extract and load process. So here's the column name, and these ones are actually enabled. And if an analyst says, oh, you know what, I really want avatar size, which, it's super important, we have all of that data type. We have the name, we have the length, we have all of that configuration, and we're ready to kind of just basically turn that field on. It's as simple as saying, change this from inactive to active, and the next time our extract and load process runs, it'll automatically get that field. We didn't have to do any development work. Okay. So by building Schema Crawler and focusing on the metadata that's around, we're able to scale our extract process. We're really able to get ahead of the business and be able to say, hey, here's what's available. I like to say we give our users a menu of data, and they can pick what kind of meal that they want to analyze. Sticking with the food analogy. The menu stays up to date with source system changes. So in the source application, in our project management system or in our ERP, or in our CRM, if we go and create a new table or add new custom fields, the next time Schema Crawler runs, it updates and says, oh, look, hey, there's a new thing on the menu. And we're ready to get those fields when requested. All right. Next topic. So we've talked about our extract process. Now let's talk about loading. So how many of you have worked with CSV formatted file imports? Okay. Comma separated value. Is that right? CSV? Comma separated? Yeah, okay. It's like a common format. And anytime I have to do a CSV load, I hate it. It is like one of the worst things. It's a bad way to spend your day. One of the problems with it is it's like one of those tasks where like every field in every row needs to be exactly right, or else the whole thing fails. So you have 1,000 rows that you're trying to import into a table, and on row 999, field 56, there was a problem, and the whole thing fails, and you kind of have to go through and figure out what's wrong with field 56. And then you run it again, and you find, oh, there's a problem on field 57. And it's just a huge headache. So with Schema Crawler and our ELT-based approach, we're able to prepare for a way to store lots of data in our platform, and we want to be able to stabilize our load process so that we don't have like some of these problems with CSV imports where when you hit an error, it just fails, and you now have like a down system. And the rest of the data is, you're sacrificing the rest of the data just for this one field that's having a problem. So the way that we solve that is by adopting semi-structured data in our platform. This really helps us do that. So what do I mean by semi-structured data? So at Tableau, we're using JSON. So here is an example of one row of data in JSON format. The JSON data structure format uses name-value pairs. So here's an example of my user record from our project management system. And you'll see in this JSON string, there's no data type or there's no format kind of specified. If this was CSV, we would be importing this row of data into a structure that kind of looks like this. So here's a table, and here are all the columns, and here are the data types. And this looks like a standard kind of table in your database. Every field has to fit and be correct for each data type, and anything that doesn't will be a hard stop for your load process if it doesn't, if the schema doesn't, fit into this table. So instead of this, we're going to take our whole JSON string and instead store it as a single column in Snowflake. So this is actually what our tables look like. It's a single column. We actually have like a couple of other columns, but really, this entire row of data is put as a string into a single column, and that's how we're storing that row. The great thing with JSON is that the structure of our data is not tied to the ability to load it into the warehouse. If that string all of a sudden gets a new column or one gets removed, we're still importing that whole string and putting it into that single field. It doesn't affect our ability to load the data in. So we have a kind of a complicated string now in the database. How do we actually get value out of that? In Snowflake and in other warehouses that handle semi-structured data, you'll get functions where you can parse out JSON and return it as a standard kind of scalar table. So here is a function. This is the function here. It's the JSON raw data function. And what this function is doing is it's asking for the ID column. So it's looking in that long JSON string and it's saying, hey, where's the ID key value? And it's going to return the value for, if it finds ID, it's going to return the other value on that colon for what that ID is. And then the last thing that this function does is returns it. Here's where we're applying the data type, and it's returning it as string. So where did I get this information for the string data type? That came from Schema Crawler, what I was talking about previously. So in Schema Crawler, we're getting that data type, and we're storing it. So we know that this ID column is a string, and we're able to apply that to this function when we're calling it out. And then below down here is the row of data, which looks like a standard row. And in Tableau, it sees it as a regular table. It doesn't see this. Well, you could actually pass this in as custom SQL. But what we do is we materialize this as a view. So we have a view that does this function, and it flattens all of the JSON string into the structure that Tableau expects it to be. So what does this do for us? Really, it protects us from schema changes. So let's pretend that there is a field called priority in my source application. And we've been extracting and loading this priority field, and it's been coming into our warehouse. For whatever reason, the field got removed in the application. I don't know why. It just could be they were doing something either accidental or maybe it was intentional. But they didn't tell us, and so we weren't prepared for it. So they removed the field, and the next time our extract and load process happens, this key value pair doesn't exist. But when we try and flatten it, or when we try to expose it, it still structurally works. We have priority. It just returns a null value. So the query still works. We can still query this table. We can still query this JSON data. And we're still putting a structure around it. But we're protected from changes that are happening upstream. If we weren't storing or parsing the JSON, all the other columns and rows with the import would have failed because we were missing this priority column. But we're able to handle that. It's not failing. Storing as JSON and parsing it at runtime has been a great improvement for us. And it allows us to scale with the amounts of data that we're serving with Metaphor. So, the common theme is here, we're wanting to get more data, And these are some of the techniques. The schema resilience and storing at JSON just allows us to be able to handle more data coming in without it being a break fix every time some little blip happens. So stabilize your load process by using JSON. There are other formats, other semi-structured formats. There's Parquet, there's Avro. At Tableau, we're using JSON. Simplify your loading by removing that data type constraint. We're just loading string. And doing this, it provides schema resilience from changes upstream. So your other teams can make the changes they need, and it doesn't have to go through a ticket. We don't need a ticket now. It's just like, hey, that's fine. If you want to remove it, it's removed. So from a data warehousing side, ETL to EL with optional T, this architecture really was a mindset change for us. And it allowed us to really adopt some of the benefits that we see from the cloud, from all of those, the traits that I listed earlier. And in order to scale our extract, we had to start looking at metadata. So metadata is the way that we're able to really turn that conversation around and go to our analyst across the company and say, here's what's available, tell us what you want, and then we can return that or respond to that very quickly. And by simplifying our loading process using JSON, it just runs. It runs all the time, and we just don't have any of the issues that we used to have with the daily changes or blips and issues that happen. So it's a way that we've been able to really scale our loading process to handle all this new data as well. Getting ahead of your analyst requests for data by giving them the menu has been like one of the most exciting things that I've been able to kind of go around to different teams and share with them. So this has been transformative for our team, and it's been a way that really helps us get ahead of where Tableau is trying to be or where the business is going. I'm going to hand it over to Kevin now to talk a little bit about how we're leveraging online.
Cool. Yeah. Okay, so let me reintroduce myself. I'm Kevin Bosky. I support a team of 4, 2 admins who administer our Tableau Online sites and our Tableau Online servers, and 2 program managers. One of the programs that we have internally is like the Tableau Doctor program you've experienced maybe here at conference. We call it Alpo Doctor, again, dog fooding. And then a data stewards program, and these are the folks that really live in the business units who understand the data on the ground. They're building data sources. They're publishing data sources. They're building vizzes. Every year we go through our territory assignments for our sales team, and we set up our attainment vizzes, and all those things happen, right? And finance every quarter and every year, all those things. So that's what we do. We take the data that Philip's team brings in for us. We're running into the same issues that our data warehousing team is running into. We've scaled out, we've grown. Like I said, I have 2 admins managing, I don't even know how many cores we have anymore running in our systems. And we're upgrading often because we're dogfooding our own product. It's taking their nights and weekends. We have a whole team who builds an online cloud product that does this. Why do we need to do that? So what does the cloud mean for analytics? Well, can we reduce our operational cost? Is it a no-ops for us now? We don't have to manage these servers. We don't have to upgrade Windows. We don't have to handle SAN upgrades. Can we scale? Yeah. We make it an operational expense versus a capital expense. We're no longer buying hardware that has to be thrown out in 5 years and handle new SANs and that's out of support and these things, right? We have a team that does this for our product, for our customers. We're a customer. We just don't pay for it. Can we make it available to all of our users across the world? Right? We've got sales teams in Singapore. We've got sales teams in London, in LATAM, Austin, Seattle, everywhere. So let's look at what our systems look like today. So we have what we call Alpo, again, dog fooding. We moved this to online this year. It was an on-premise Tableau server. It would run pre-production builds. We are now running in AWS on a pre-beta code. This is for our dev team, mainly. They use it for tracking bugs. They use it for tracking production issues. Bunch of workbooks, lots of views. I built this slide. I was finalizing the slide over the weekend to make sure I had all the biggest, like all the numbers at the latest numbers that we had. And it had been upgraded to 2019.1 just a bit ago. And this showed up. So we now have people building flows using Prep Conductor and scheduling them in our online system. So it's pretty cool. So the next thing we're going to do, along with what Philip has been doing to move us to Snowflake, is to move our other on-prem server, which manages our business analytics, to AWS in our Tableau Online product using beta software. So we'll still be dogfooding. We'll be on beta. We'll be moving all of this content to the cloud. Well, how are we going to do that? Let's talk about how we can do that. So there's really two ways to convert your content to cloud data. And really, this is actually not just converting it to cloud data, but converting from any data source to a new type of data source. In our case, we're moving from a SQL Server warehouse to a Snowflake warehouse. So doing that in your workbooks, it's replacing references. It might be renaming fields to match the schema format that you might have in your naming in your new data warehouse. You might have to rebuild some of that content. But we have a lot of content, as you saw on those previous slides. Doing all that by hand is going to take a lot of time. Some of it we'll have to do. We want to automate as much as possible. And we're going to do that by scripting our workbook XML. So if you're familiar with our product in our file format, it's really just XML. We worked with a partner, Interworks, they're here, to build a tool to do this. And we're right in the middle of this right now, so I can't actually show it to you because we're really just working through it. But I can show you what it kind of looks like. So what we do is we have a mapping file in the JSON format, and it tells the tool, how do I want to convert this file, right? So it's looking for matches on the server name and database. It's putting in these new values. As you can see, it's case sensitive, so we can do multiple different versions of the case from SQL Server Alpo, SQL Server Alpo DB, all these things to get the right values. We also have some intrinsic rules that we built into the tool. We convert everything to an uppercase in Snowflake, and we replace like spaces with underscores, these kinds of basic things that you might do. We can also then define the tables and how we map those from SQL Server to Snowflake. In our case, we are putting all of our data in the warehouse in Snowflake in a single database with multiple schemas. And that way we don't have to do any kind of cross-database joins. It's all there. So if I want to join my CRM data with my ERP data, it's all in the same database. In this case, what we're doing is we've got, of course, your DBO, which is your default database schema in SQL. Some cases we'll just go into a database, that same database schema. In other cases, we want to say on particular tables, we're going to put them into a new schema. Hey, I want to put support cases away from sales leads, things like that. Here's what a sample of our XML looks like. And you can, of course, open any workbook file and see this in a text editor. This one here is pointed at our SQL Server. We call it Alpo. Again, dogfooding. And we run it through the converter, and we get a sample that is pointed at Snowflake. And of course, there's a bunch of other changes in there, like the field names I spoke about, underscores or spaces to underscores and capital letters, things like that. But we do this, and now we've pretty much got a thing that works. Occasionally, there's some things that we don't handle. Custom SQL, of course. If you've got custom SQL in your workbooks, it's not going to handle that. You're going to have to rewrite that SQL. There are a few other things. The recommendation, though, is to use published data sources. If you've got a published data source, all you need to do is convert that data source, which you can do with workbook or XML conversion, and then just have the workbooks point to the new data source. Replace those references, boom, you're going. It also works with pushing that content and down to the people who know it, the data stewards of your data who are now building those aggregations, who are building those conversions, those transforms that we used to do in the database. It's living in the product at Tableau. So migrating to online. So you saw, again, we have a ton of content in our on-premise servers. Now we need to move all of that content up to online, and we want to do that without impacting our users as much as possible. So the way to do that, we believe, is to use the Tableau REST API. You authenticate with your server, query for the content that you want, projects, workbooks, data sources, pull that down, query to online, create your site, push your data up to the site that you've queried out of your server. But you say, I'm not going to do all that at once. I'm still going to have some on-prem data. Like, we're not going to stop probably running SQL servers or MySQL or whatever else we have data in different environments internally. So how do I deal with my on-prem data? Well, the solution to that is Tableau Bridge. It's an on-prem agent, runs in your environment, behind your firewall, connects to your data. You can either do it as live connections or as extractions. This only supports their published data sources. So this is looking to do published data sources to online. And you can do it with live, you can do it with your relational databases. So, quick recap. Cloud analytics, low or no ops. Well, we've avoided having to manage our servers. We have a team that does that for all of you and us. Can we scale? Absolutely. Have we moved from a capital expense? Yes, we're now in a subscription model. We buy our subscription online. Of course, we don't. It's free for us. And we get our analytics anywhere, right? It's no longer like, oh, I got to connect to the VPN. I got to get VPN into the way I can't get to my VPN. It's too slow. It's where we're at. So, quick recap of best practices. Use published data sources, use published data sources, use published data sources. Consider online. Reduce your operational overhead. Stop worrying about networking. Stop worrying about your SAN that just went out of support, all these things. And if you're concerned about how do I manage all the users for online, consider SAML. Use an IDP. You can connect with your Active Directory. Skim is a model that's coming out soon for users of SAML. And use the API to migrate your content.
Thanks, Kevin. We hope that the story that we've shared of how Tableau has kind of grown shows that how moving to the cloud is really the right choice for us for our use case, and maybe it applies for you as well. By doing that and adopting and changing our processes to really fit with the cloud structure, we hope that we can be able to transform analytics from something like this, which is how it used to feel for us and our team. It's like, we're going to get overwhelmed and eaten, I don't know, by a hamburger, to something more like this, where we can offer our analysts all of the data that they want. We can give them more than they need, and then change our primary function from being, responding to data requests to more of helping in governing, how we're using your data. Oh, what data is most important? Which ones do we actually need to focus on from a training or an education and awareness standpoint? So that's the Tableau story for where we are now. Thank you. And again, please fill out the survey if you can. It's really helpful for us to get that feedback. And we'll do questions. Yes, thank you for waiting.
So actually, I have two questions. Where does data governance fit with the new model, ELT?
So data governance fits in it's partially into the T part of the model and part of the just the data warehouse, right? So at Tableau, we have typically given everyone access to the data that we have with reason, right? Obviously, we can't give everyone the financial data or HR data. Those things have to be protected. But the governance goes down to the data stewards who are using published data sources.
So those sit on the business side then?
They do, yes. So so typically what will happen is a data steward will produce a published data source that says, let's say, leads, right? lead funnel, something like that, right? That's the place that we would send people to go to. Hey, you have questions about leads? Go to this data steward and use their published data sources. No, the standards are kind of held by our team in the sense that we own access to the databases, and then we have best practices around what we do, right? If you're publishing a data source, is it like Philip said, if you have a bad query, we'll kill it. Like we'll help them produce the right kind of query, things like that.
So like at Tableau, governance is really tricky. Or I mean, not at Tableau. Governance everywhere is pretty tricky. Like it's a fine balance. So at Tableau, yeah. So at Tableau, what we do is actually we are pretty open. It's one of the more like enable but verify kind of thing. Because if you're a little too heavy-handed, and especially at Tableau, if you're heavy-handed, your users are just going to go and use their own system and something that you're going to lose the awareness of. So with our cloud data warehouse, what we're actually doing with Snowflake is we are persisting all of the, I forget what they call it, the system views. So we actually store every single query and who issued it and, and how long it took. Like we kind of track those metrics. And we use that data actually to say like, looks like a lot of people are accessing this field or actually this table. That's really interesting. That one's not actually live yet. We should really kind of go and follow up with that. So it gives us the information we need to follow up.
That's my next question. When you say they're accessing this field, how do you know what field? How are you getting at that level of detail?
Yeah, that's tricky too. Right now, we have to parse query strings. So we have to say like, oh, it looks like there's this really long from statement with like lots of tables in it, and we kind of have to figure out like, oh, okay, so that means they're accessing this field. It is something that we hope to get better at, and it's kind of a key to our governance activity. And then on the Tableau side, the same thing applies. We have like admin views and custom admin views where we can see like, oh, who's accessing a view, who's reading it, who's publishing it, those types of things.
Yeah, and that's not to say that we don't also have those folks that are going out there and going rogue, essentially getting their own data, right? We do have people using Alteryx to build data sources of their own. We have people using Prep to use data sources of their own. We have people using CSVs that they can pull down, things like that, right? It just becomes a pattern of like, hey, best practice is use a data source, have a single version of the truth, right?
Any other questions? Yeah.
How often do you run that schema crawler to your source systems?
I think we have it variable, like it depends on what the source system is. I think like now we do it like daily.
The example that you mentioned, before you discovered that priority is missing, you would expect that to be there if your schema was still expecting that to happen. But the priority is, if you ran your schema crawler last night or in the morning, and then do the extract, then it'll match.
Correct, yes, right. So actually in that, there have been instances where it's like, oh yeah, we have something going on, but we just need to run schema crawler again, and then that kind of right sizes the system or corrects all of the expectations.
I mean, in the past, what would happen is the team that operates one of those SaaS products, maybe it's the Salesforce app, would add a field, for example, and we would have to know about it beforehand so that we could set up and be like, okay, this new field's going to come through.
Yeah, the biggest thing that happens for us is adding new fields. We hope that Tableau gets to a spot where we're actually like removing unused fields, but we're not there yet. So most of us it's adding new ones. That's the one that we have to handle most often.
Is schema crawler available?
It's an internal tool that we're writing for our team right now. So no, it is not available yet, but it's based off of all of those public APIs that all of those source systems have. And so you call those and you're really just storing, it's another extract and load, like we're extracting the metadata about our data and loading it into our warehouse to use for processing.
Sources, and you're saying these are all the fields that are available, and then creating some sort of web page that tells them what's available, or they can go and select what they want, then create.
Yeah, we're not at the web page yet. Right now we have a workbook that's just connecting to a database and then showing people like here's the fields that are available. Yeah.
You don't face any resistance from the owners of the source system because
Yeah, actually, we want to get to that spot where we actually make the schema crawler data available, and the owner of that system can say, yes, I want these fields. And so we still need to make sure that there's an understanding of what it means when you say, yes, I want this field, which that one is less impactful, but more if we ever get to like, no, I don't need this anymore. We want to be able to say, oh, well, did you know that, this has been queried like yesterday, 100 times. Maybe you don't want to, remove that field yet. But yeah, this is not something that we expect we would have an owner for certain tables. Maybe even at the table level. And so like, this is the person who is enabled to like make changes to say like, hey, we'll bring in this new field or not bring in this new field.
There's kind of a flip side to governance there, right? Where we have a relationship with the teams that own those systems. We're not just pulling stuff without them knowing, right? They can decide if they want something exposed or not.
Really what I want to do is before they say, yes, add this field, I also want them to fill out, well, who is the business owner of this field? What's the definition? To kind of help build our understanding of what does this data actually do, and where do we go to? Because the most challenging thing is how do we route requests when people ask them? It's like, oh, you have a question about this field? Go talk to so and so because they're the owner of the field.
Yep.
Yes.
I want to ask a question about which tool you use to load your ELT to Snowflake?
What do we do to actually load the data? We're actually using Talend right now. Talend is it's a ETL tool. Yep, it's an ETL tool. We're just ignoring the T part.
So, and do you kind of evaluate any other tools? So I'm just wondering if there are multiple. I know for Snowflake, and kind of thinking which one to go with. If there's a criteria, right? So do you evaluate, or you just nature kind of go with that Talend for whatever reason?
We went with Talend for a lot of reasons. I don't know if I can explain all of them. Not all of them were technical. Really, we went with Talend as a unifying activity. So I mentioned it briefly, like we had all of these different technologies, Anton's on vacation, we can't answer the questions. By unifying all of this in Talend, we were hoping that, or our goal was like, yeah, we just want to be able to have a single code base. So it wasn't really specific to Talend. We used Talend because there was some other adoption across the company as well.
Okay, and I also want to ask about your dashboard that you use to track your ETLs.
Mm-hmm.
Is it like driven by whatever Talend is collecting about the ETL, or is it driven by Snowflake, that Snowflake knows whatever you loaded?
No, that data is driven by Talend. So in our ETL or in the stuff we write in Talend, we're actually marking certain key steps so that we can monitor it.
Okay.
Yes, Jennifer.
I was interested, you didn't mention anything about time and like how often you're doing extracts, and did that change between the different ETLs and ETLs? Was that a goal or not, and did that change at all?
Yeah, we do have a goal to be able to get data faster and faster almost to like where it's not technically streaming, but it's like micro batches so that they're just small incremental loads. But right now, I think we are querying data every half an hour. That's kind of like our fastest. But we do want to be able to intelligently bring that down and be able to like have that run much faster.
And that's, we do that today even with the warehouse way it's set up, and then we have an additional latency of the replication piece, right? And if that gets backed up, it gets even longer.
Mm-hmm. And we want to use the data that we're getting on our process too to be able to say like, well, yeah, you want it every half hour, but really the data is not changing that much, based off of this or historical trends. Like here's 7 things were changed. Does it really need to be? We want to just be able to have data to be able to have those conversations about what is the urgency or frequency needed.
Yeah, I guess follow up to that. Have you seen big performance improvements or even being able to go from extracts to combined versus SQL?
We have a lot of live connections to our SQL Server already, even in our data sources. We have some extracts. I don't think we have enough data yet to say what's going to happen. I think it's mostly going to be live.
We're doing on a scale of like 80 million records, a refresh, like once a day. So we'll do something to that large where we're getting that much data in one instance of the EL process. Yeah.
But are you asking about data sources, extracts versus live?
Oh.
Yeah, okay.
Oh, extracts versus live. Okay.
Some of the things that we've done in the transform layer of the current warehouse, we did because of limitations in the product years ago, right? We've done aggregations there because it wasn't available in, say, Tableau 8 or whatever, right? And we've added over time, we've gotten better, and now we don't need to do those things. So we'll see that change as well, and then those will get pushed out into the data sources.
Yeah, at Tableau, we have a lot of teams that prefer live. We do both extracts and live connections. We have a lot of teams that prefer live just because it's a little simpler. They don't have that double hop of understanding, like, oh, when is my data really current? But extract is definitely still the high performance bar. That is the fastest way that you can usually get your data. And so we actually need to have systems like Snowflake that can support a lot of extracts happening.
Yeah, I guess that's just go from that traditional tabular.
Oh, with the JSON? They're yeah. Well, actually, by doing the JSON, there is a little bit of overhead in that because we're parsing it all out. But our thought process is it's such a good practice that I'd rather just pay for more cloud processing to handle it.
The self-serve data source, where you're allowing people to bring in their own data sources, are you supporting those data sources for them they're bringing them into the sandbox? Do you support that then?
Oh, you're talking about the sandbox in the data warehouse?
We have a lot of rogue users that go out and bring in whatever they want into their own little Tableau environment.
Mm-hmm.
But then they call us when it doesn't go right.
Yeah, we've had that same thing in the past as well, and that's what this helps us get away from.
And then we're like, I have no idea what you're doing. And I end up spending a day just trying to reverse engineer what they've built and why it's not working.
Yeah.
But I also support it through to the biz as well. So it's not only, it's checking to see if the biz is doing it right, but also did we get the data as we expected to receive it.
Yeah, it's a challenge. Yeah, we do try to be upfront. It's like, hey, this is self-service. You're loading the data in. We trust that you're doing things well. We won't be able to respond to everything, but we're here to help if you do have questions. It's that fine line of like, yeah, I want them to use this service instead of them going out and finding something or doing it in Excel or doing these things in a system where we don't have visibility.
Or building an Access database that they hand to us and say, please upscale this to
Yeah,
SQL.
right.
Never happened to anybody else, right?
Yeah. Okay, thank you. If you have more questions, we're happy to talk afterwards. I know that some of you might be traveling. Thank you for staying to the very end of conference, and yeah, thank you.
Thank you.
Yeah.